Hey, hi. Um, this is day 21, so very excited. 21 days of doing this, which is nice, but I think it would go a long way. I'm on mute like yesterday. Uh, so, what we'll cover today is more exploratory data analysis. And so, it's like when we're doing PCA, which is actually dimension analytic reduction, it's also one of the pre-processing steps before building a model or training a model kind of stuff. So I thought let's explore that in little detail as well on what are the other things that we do from receiving a raw data from input sources and then to started training the data and kind of stuff, right? Whatever we do in between, let's cover what are all the steps. Maybe ask ChatGPT to explain what are all the steps that are usually done. Um, uh, And that's one thing, and we'll also cover, try to put together plan on. We'll move to the next stage. Officially, today I'll call out the ML focused area piece part we'll complete it. What initially I thought was to go with ML first and then DL and then to NLP, but NLP and Gen AI is nothing but is part of NLP itself. Uh, so we'll cover neural networks, CNN, RNN, and other models as part of NLP itself, the starting of NLP itself. And it will also cover Gen AI. So two steps, ML and then NLP. These are two things we'll cover to get into Gen AI. Once we get into Gen AI is where we'll start exploring more models frequently kind of stuff. So in the end of the video, we'll try to plan for it. I think from today we should actually also focus on putting up certain time for each of the things so that it will be much more practical. Um, the charging is low. So 6:45. Technically, I'll have time till 7:30. Let's say 45 minutes. So maybe I can spend less than 45 minutes should be good. But let's say I'll spend half an hour on EDA and this thing and 15 minutes on planning. So this will be for EDM. 30 minutes. So let me share my screen. Let's get started. Um, okay. I hope you are able to see my screen. EDA, that is exploratory data analysis. The word looks complex, but it's more on explore doing an analysis on data which explains what the data contains and stuff so that we are very familiar with the data that we are trying to put in, which also helps us in taking calls what kind of a model or what kind of features, what kind of a model uh, we want to derive, and then we will also have certain level of understanding on what is the corresponding y to given features. I mean, we'll classify whether it's a supervised problem, unsupervised problem, like that. We can classify multiple things based on that, right? So explain EDA, expert data analysis, feature engineering in steps as detailed as possible. Sure. Data science or machine learning project. Let's break down each process into detailed steps. Exploratory data analysis, data collection, gather raw data from various sources such as databases, files, APIs, etc. Um, Initial data inspection. Load the data into your preferred tool, example Python libraries like Pandas. Yeah, checking the size of the data set, number of rows and columns. Display a few initial rows to understand the structure and format. Check for any missing values and data types of each column. Okay, that is initial data inspection. Very nice. Statistical summary. Compute the summary statistics such as mean, median, standard deviation, minimum, maximum, etc. for numerical features. Minimum, maximum, and mean median will tell us actually how much the data is spread. And it's like, is the data very close? Is it the data spread? Like the minimum and maximum values highly varying on scale. For example, if min is 0.1 and the max is 100,000, they're distributed. We can't say they're distributed, but the range is high. Um, Mean will tell us roughly saying if we are dealing, if this min max are actually outliers or are they realistic points. The mean should be the mean. If it is closer to min plus max by 2, that means the numbers are more distributed, most probably. Not exactly, but most probably. And median also so similar lines. If min plus max by 2 and mean median are close by, then could be the numbers are distributed more between min and max kind of stuff. But that doesn't say exactly. But what can say is standard deviation. The standard deviation says if the mean is shifted to 0, how much distribution does these remaining points have? Relative to that particular 0 is reflected by standard deviation. So the average distance of all points from the center 0 point is what is reflected. So that gives a standard deviation. That gives us actually how much distribution is there. The higher the number is, the higher the distribution is. That means they are further from the mean. The points has a mean of certain value, but these points are actually further from the mean. It could be an indicator saying there could be outliers. They're away from far away from mean, so they are influencing the standard deviation, mean, median, all that. Will be influenced. The maximum values also will get influenced because of those values. So those all can be identified by computing the statistics. For categorical features, what we'll calculate is counts and unique values. So we'll try to identify how many, let's say, categorical features. We can actually find out how many classes are there. That analysis can be done on categorical features. And data visualization. Um, so here, what happens is even those 2 3 steps sounds easy, but the challenge with those steps is it depends on the data, right? So it could be huge amount of data. So at times we may not be able to run or load that particular data into your session. So we might not take the whole data into consideration. We'll take a subset of data and do all this analysis and stuff. Um, um, but to understand this data better, with respect to how the data is distributed, how the data is varying, we would actually go with the graphical representation of this data to see how they are varying basing on y values kind of stuff. So we can plot histograms The histograms, usually what we do is, if there are n features, then we'll go with uh, n into y, n into 1, where we don't try to put all the dimensions into one graph, which it is, I think it's not possible to plot a graph. You can go for 2D or 3D curves, but more than that is not possible. We can't practically represent it. So, at least on diagrams, considering that feature, what we'll do is we'll go with only um, each feature's correlation with y to represent how those features are varying with respect to y kind of stuff. So, that will be the plot histogram. And then we use box plots to identify outliers and understand the spread of data. Like box plot will show you how much spread they are from the mean kind of stuff, and they'll also represent the outliers that are there. Um, Create bar plots or pie charts for categorical features to visualize their distribution. Yeah. So what we'll do in for categorical values is we'll represent a graphical representation of counts of individual classes. So how many, let's say there is A, B, C, D as the values in a categorical feature, then how many A's are there, how many B's are there, how many C's, how many D's are there. It's more like group by of that particular and then taking count of the whole rows. And we can also subclassify for each category what is the corresponding Y value. Basing on that also we can actually mm, put that detail into graph to see how much correlation is there between this class, like certain class giving 90% of y positive, 10% y is negative. This is a kind of something we can look at categorical values and to understand how they are behaving and kind of stuff. And if we see more categorical values, that's also an identification count of number of categorical values to number of numerical values, because as I said, the primary intention of going through all that is to take some calls on how do we do feature selection and how do you do model training kind of stuff. The objective is not to train the model once, the objective is to train the model iteratively. So so as I said, iterative. You make a choice of models, you train them, you implement it on the ground, you get some feedback. Our second thing is you might also receive more data. So now you keep retraining the model. So the first time you set up a model, preferably we can change, but preferably the expectation is we stick to similar model. That means if there are 20 features, we're picking up 10, and in those 10 features we are standardizing or normalizing with this approach. We do certain steps right before training. Those all steps will be standardized, saying even if I get more data, I'll go with the same thing. So it's not one time process. It might become a process which will get repeated multiple times. So considering that fact, we need to make a call on these points very in detail. Come first. But the thing is, before taking a call on what all transformations you do on data, you should understand it better. So these steps, one, this exploratory data analysis. Exploratory data analysis will explain you what all steps needs to be done. So we can randomly pick some choices. For example, you pick a range, assign some classes, assign something, and stuff. You can do it. So all of them will look good. Like normalize everything to -1 to 1 or something like that. You can do it as standard approach. But are you, for example, you can drop off all outliers, but certain calls will impact on your overall performance, because you might call something as an outlier, but for that particular feature it makes sense to have outliers. So the calls are very subjective. You can't generically take certain calls saying, okay, I'll drop all outliers, I'll only pick up features which are having more count, um, or I'll just standardize the whole numbers. So this all will impact your output, because let's say the y is a continuous value, not a side value. So then you need to see how closely you need to predict y. So I mean, of course, you if you scale x down, you can scale also y down at the same time, so that your algorithm gives you relative values with respect to y. But the accuracy of the values will definitely be varying compared to scaling down a certain value to scaling up to the actual values kind of stuff. Those all calls will be taken based on the computation capability of your environment, and also the excuse me, and also the data size of what you're dealing with. Is it few gigabytes? Is it terabytes? Is it petabytes? No, no, right? Anything is possible in real world, based on the domain that you have and the availability of data and all that stuff. So data visualization, you create bar graphs and pie charts for categorical values. Use scatter plots to explore relationship between pairs of numerical variables. Plot correlation matrices to identify correlation between variables. So correlation matrix is something which we have seen in PCA, where they calculate covariance, and basing on covariance values, they build a graph which reflects uh, relationship between two features. So what we do is, if there are n features, we create n by n matrix to see how is the correlation between all the features. The As we did there, dimensional reduction is the primary objective of looking at the covariance matrix to see how many features are very close to each other, so that the influence that they make, if they're very close to each other, when you train the model, the influence they make on y will be similar, because they're just numbers, right? Like if it is 1 2 3 4 and the other one is like 2 3 4 5, the patterns is what we are trying to achieve in the model, right? So if two input features, the pattern we try to find is between the input features and y. And within the input features, if there are certain features which has similar pattern, um, if you find out the pattern for one number, the pattern for the other number is going to be very much similar, right? So the identification of pattern is to find out y. So if x1 and x2 have similarity to a level that they have same pattern to identify y, why do you need to find patterns in two variables? Right? You find out a pattern of x1 which will correspondingly map and give you y, then you're good to go with it. So that's the whole objective of dimensional reduction. So after data visualization, he says feature relationship. Analyze relationship between features using techniques such as scatter plots, pair plots, or heat maps. Identify potential patterns, trends, or correlations in the data. Handling missing data. Decide on a strategy to handle missing data, such as imputation, example, filling missing values with mean, median, and mod mode, or deletion of rows or columns with missing data. So, um, missing data means within a column, certain data is not filled, it is null, RNA kind of stuff. So, in that case, what would happen? That data not being there in a given equation, so like w1 x1 plus w2 x2 plus c is equal to y. So an x2 is null or 0 or whatever, let's say, then w1 x1 plus b will become y. So it solely depends on w1 x1, whereas till that feature is w1 x1 plus w2 x2 plus b is equal to y. So there is the influence of x2 will be gone because of that being null. So when you're training the whole model, the w2 parameter that is output of your model, right? W1 w2 is actually the equation parameters, which are actually the inputs of your model to run that particular equation to execute it, right? So um, those will get the value will get influenced because of having certain values which are zero kind of stuff, or null or zero or not available kind of stuff. So to address it, what we'll do is scenario that we should look at is um, how many are there values, and again same thing for that particular missing values. We can actually also see if what's the kind of relation between the other features and stuff. Okay, the closest features kind of stuff. That will also give us certain indication on what should be our strategy to fill those values. So there are multiple ways of filling those values. Either we can use a mean mode values to be replaced in that particular value so that they are within the range of the values and also doesn't impact the mean value much, or in turn the standard deviation kind of stuff, right? So almost they are dummy values because the variance or standard deviation that they contribute will be zero, because if you keep mean, the distance between them and the mean will become zero. That means the overall standard deviation or anything will become zero. um, they don't have much impact. So handling missing data is something we looked at it. Okay, we could also go to an extreme saying these values are critical, so guessing them is a wrong idea, and they are distributed very high. As they are distributed high, they are not close to the mean. Putting mean there is not a good idea. So we can also take an extreme call saying, okay, we don't know the data, so let's not use the data. So we drop off the data. That could also be one of the strategies of handling the missing data, right? So outlier detection and treatment. So identify outliers using static analysis or visualization techniques. Decide whether to remove outliers or transform them based on domain knowledge. That is rightly said. The outliers are okay. That's 22 minutes short, but I'll continue study, but I might not record it for today. I had to take in between. Okay, that's it, guys. I'll give a summary of what I've studied today tomorrow, and then we'll continue tomorrow.